So I want to talk about an Eclipse XL. That's what this guy is right here. This one happens to be a 40 by 32, and it's on an adjustable stand. Like, it can be tilted, the tabletop, or it can be raised up and down. Also, you can see the serial number starts with the letters XL. Okay, so this one I happen to have a Windows XP computer running on it. It can run up to Windows 10 32-bit. If you're going to use the Wizard software, then it has to use Windows XP. But if you're going to use the Eclipse software, it can run up to Windows 10 32-bit operating system. There are ways to upgrade the machine to a 64-bit operating system so you can use Windows 11. Those are in other videos, but I just want to give you an overview. Okay, so this is the motion controller card, what we call the motion controller. It goes in the PC. It has a PCI slot, so that makes it difficult to find brand new PCs because that's a 32-bit bus, not a 64-bit bus. All right, so the key is right here. See these three blue jumpers? Right now they are not across the two pins. And you see how it says SMX, SMY. See, maybe it'll focus, I don't know. But anyways, when you're going to use this motion controller card in an Eclipse XL, you need to move those jumpers so that they span the two pins. Right now they're just hanging on one pin as a spare. So I would be using this on Eclipse Pro, but if I would move those jumpers up there and reconfigure the memory, I can use it for Eclipse XL. So I'm just pointing that out. All right, so let's work on some testing. So again, on this, and you can see in another video, see I've got Windows Servo Design Kit here for the Galil, and I've got Smart Term. There is another video that shows the difference between those two programs. I'm going to use the Smart Term in this case, because most people who have Wizard software on their machine also have the Smart Terminal. So I will double click on this. Okay, so there's my terminal. I type commands in here. I get feedback from the controller here. I can write a program here. If I go to Tools and Display Data Record, I will open this window, which shows me live feedback for the controller. Like, you see how this number is running. It's continually sampling the controller card, and it's asking about our inputs on or off, and home switches on or off, and all that kind of stuff. And look right there, SM, stepper motor jumper installed. So it says, yes, the stepper motor jumper is installed. Now, what you won't find on an Eclipse XL is you won't find these position numbers and error numbers changing, because there is no feedback from the motors on the XL to the motion controller. It's just the motion controller instructing the motor where to go. The computer basically crosses its fingers and hopes the motor did it. And that's stepper motor business. Stepper motors typically don't have feedback. They can, but they typically don't. Okay, so you won't see some of these things down here that if you're watching other videos of mine that are made using Pro machines, you'll see feedback and things. So don't expect that on XL. All right, so if we're gonna type, we're gonna type in commands in here, and we're going to have our caps locks on the keyboard, and we're going to then type a command. The commands are all 2-letter commands. So let's type an example one, like S for set, B for bit, and the number 2. And what that does is that turns output 2 on. Output 2 runs the valve, which extends the head out. So when I press enter on the keyboard, this command will execute. So we'll look at the cutting head and we'll press enter, and it extended the cutting head out. Okay, if I want to get rid of that, I can say clear bit 2, and I can press enter. And when I press enter, it will turn the valve off and the head will retract. Okay, so we verified that. Also, let's just do that again. So set bit 2, and when we pressed enter, that box turned blue. And when we type clear bit 2, and we hit enter, that box goes off. Okay, this input 3 is on right now because we have air pressure. There's a pressure sensor on the machine right down there between the 2 valves that plugs into that white plug right there. And because we have air turned on, that input is on. Another input is input 2. That's emergency stop button. So over here on the side of the machine, we have emergency stop button. If we push that in, it cleared that box right there, input 2. If I twist the button and pull it out, so now I know my emergency stop button is working. Input 1 is the clamps. So if I turn the clamp button on, or if I had a foot switch and I stepped on it and I turned the clamps on like that, input 1 is clear. So that's how the Eclipse software knows if the clamps are on or not, so you don't actually cut a mat where you forgot to turn the clamps on. All right, so if I release the clamp button, now the clamps are off. So those are the inputs. There's another output that we use, output 3. So set bit 3. That turns the power to the drives on some machines. We just execute it and use it on all machines. And so when we do that, it turns that guy on. And when we do clear bit 3, it turns that guy off. Okay? On some machines, there is a brake at the top of the arm, like this machine in the back right here. Right up there, there's a gold brake. So if I had that machine back there, I would need to do set bit 6 to release the brake. Some XLs have a brake, and so this is important. Set bit 6 is the brake, and that turns that output on, and clear bit 6 turns that output off. Okay, so if I ever want to clear the window, I can right click in the window and hit clear. Down here, you notice there's a bunch of colons. Every time I issued a command up here and there was no problem, it gave me back just a colon. It didn't give me back any error message. So for example, if I just type some garbage up there and I hit enter, it down here it says, hey, unrecognized command. Okay, so I'm gonna clear this and I'm gonna clear this. All right. Okay, so let's make some motors move. So the first one I'm gonna make move is the cutting head. because it's the least dangerous one. So the first thing I'm going to do is I got to type set bit 3 to turn the power to the drives on. And then I got that over there. And then the next thing I need to do is so right now I can move this, I can turn it, okay? I don't want to be able to do that. So when I type right here, S is in Sam, H is in hold, so servo hold, and then which motor, Z, and I hit enter, then that changed this box right here. It cleared it, so this motor is now on. And if I go down here and I try and turn this motor, I can't turn it. Okay, so that's doing its job. It's holding its position. Okay, if I want to move it, I'm going to do position relative. So hey, go from where you are, and which axis? Z axis. And how far do you want to go? Well, let's say 2,000 steps. Okay, now we'll talk about how I know it's 2,000, but this will work for now. Okay, now when I press enter, all that does is load the motion into the motion controller card. Okay, it doesn't actually move the motor. Now I have to say BG for begin and Z, and when I press enter after that command, it will turn the cutting head in the positive direction 2,000 steps. So if I press enter, it moved that, just like that. Okay, if I did BGZ again, it would repeat the instruction. Okay, so I know that's working. So now I want to tell the cutting head to find its home sensor. So I'm going to use the command FE for find edge, and Z for zebra for the Z axis. And now I'm going to, that was just like this command up here. It didn't do anything. It loaded an instruction in memory. Now I got to tell it to do it. And so when I do that, when I press enter, the cutting head will spin around and find the home switch and stop. So that's cool. So that found the home switch, and if I look, state of home switch input, Z is clear, meaning I'm on it. Okay. That's X. I pushed the arm over that way, so it wasn't on the home switch anymore, just to show you when you're not on the switch, it's red. When you're on the switch, it is white or cleared. Okay, so now your mat cutter software will do one more thing. It will take this head and turn it back around here based on the hook setting in your machine. And if I'm not correct, if I'm not incorrect, I can say position relative Z equals 3,890. I think that's the number that's in the software. Okay, so if I hit enter, then that just loads it into memory. And now I'm going to do it, BGZ. And when I press enter, yep, I guess pretty close. It's not exact, but it's pretty close. So that's the way your cutting head works. All right. So now if I'm going to turn this all off, I'm going to say, okay, I don't want the motor on anymore. So motor off, Z, enter. And I don't want the power to the drive on anymore. So clear bit 3, enter. And now I've turned that all off. And now I can move it again. It's all free. All right, so that's how to do the Z axis. So we finished testing the Z axis. So what I'm going to do is I'm going to right click on this window and I'm going to clear everything, and I'm going to right click on this window and I'm going to clear everything, I didn't have to, but I like to start with a clean slate. Okay, so now we're gonna test the X direction. So your machine is X positive this way, Y positive this way. The corner of the table is 0, 0. So right now this cutting head is sitting in negative X space and maybe a little positive Y space if I were to close it or imagine the center of that curved cutout in relationship to that point. So, okay, so first thing we got to do is turn the power on to the drive. So set bit 3, and we don't get a choice of which drive. This is turning the power on to all stepper drives, X, Y, and Z. Okay, again, it shows up over here. Okay, now I'm going to tell the X axis to hold. So servo hold X. Enter, and you hear the little noise, and now my X motor is on and the other two are off, and I should not be able to move the arm. I'm shaking the whole machine. Okay, so that's doing its job, it's holding. So now I want to move it, so I'm going to say position relative from where you are. Let's go in the X direction. How far? Oh, I don't know. Let's go 4,000 this time. Press enter. Remember, this is just load the move into the memory of the controller card. Now we want to do it, so BGX, and when I press enter on that command, it is going to move the arm. So let's see. Okay, so that was 4,000 steps. So you can imagine it went, I don't know, 3 inches in 4,000 steps. So, you know, it went from here to there. So it did it. And it's still holding. This is good. Okay, now I want to bring it back to the home switch. And so I will say find edge X. And that's just a movement that goes into the controller card. It doesn't do anything. And then I want to actually do it. So BG for begin X. And when I hit enter, it's going to move, and we'll focus on this corner right here. Boom. It found the home switch. And the home switch is there. Okay. So it found the home switch and it stopped. So our X works. So we want to shut it off. So let's do motor off, X, enter, and we got to turn the drive power off. So clear bit 3, enter, and now we're back to being able to move this left and right. Okay. So now that's it for the X-axis. Okay, so we finished with the X-axis. Let's clear this and clear this, and then let's do the Y-axis. So first thing we gotta do is turn the drive on. So set bit 3. Okay. Now, servo hold Y, so it will hold. Right now, I can move this carriage up and down the arm, which that means the motor's not holding, and I want it to hold. So when I press enter, I will no longer be able to push this up and down. It's locked in place. Okay, now, if my machine had a brake, I would need to do set bit 6 to release the brake. And so now the motor's completely got a hold of the cutting head. So now I want to test it. I want to move it. So position relative Y equals 4,000. And I'm going to press enter, and it's not going to do anything. It's just loading it into the memory. Oops, 4,000, enter. Now I'm going to execute it. So BGY, and if I watch the cutting head and I hit enter, the cutting head went up the arm. All right, so that worked. So now I want to find the home switch. So FE, find edge Y, enter. That doesn't do anything except for load the instruction into the controller's memory. And now I want to do it, so BGY. And when I do that, the cutting head will go down until it finds the home switch and stop. Okay, so that's good. Now, if I want to shut it off, we're gonna set the brake. So we're gonna clear bit 6 to remove power from the brake and let it automatically clamp. It is a power off brake, a safety brake. So releasing the brake needs power, that's set bit 6. Setting the brake doesn't need power, so that's clear bit 6. Okay, and then I'm going to turn the motor off, and then I'm going to turn the power to the drives off. Okay, so that's how you test the Y-axis. Now we're going to make a program that does all of that. I'll be right back. Okay, let's talk about how to write a program over here. So we did our step-by-step tests over here, and we didn't get any error messages down here. So if we took those same kind of commands and we put them over here, we could make it repeatable. So let's introduce some new topics here. So the first line, you can see I have a hashtag capital R. That's the name of my program. It's program R. Okay. The next line is a NO. That's a comment. That's how you do a comment. NO means no execution. Okay. So I made a note. Hey, in the following steps, we're going to home X and Y axes. Next command should be familiar. Set bit 3. That turns power onto the drives. In this case, I'm going to turn both X and Y on together. Servo hold XY. When the Y is turned on, I can release the brake by doing a set bit 6. I can then say, hey, move X and Y out and up 4,000 in both directions. And because I'm doing 2 axes at once, I can't put like XY equals 4,000. I have to specifically talk to X and Y. Now I want to tell both motors to do it. So begin X and Y. And this is independent motion. One may go faster than the other one. And then I'm going to say, hey, wait after motion XY. So wait till this move is done before you go to the next line. And then I'm going to say find edge XY. And that's going to tell both X and Y motors to go look for their home switches after I execute this command telling them to begin. And then I'm going to wait for that instruction to complete. Okay, now once I've done all those steps, my X and Y axis are home. So I can move on to the next step, which is a comment, which is home Z. Okay, so now turn the cutting head on, rotate the cutting head 4,000 steps in the positive direction. Do it, begin Z, wait for it to get done. After motion Z, you can move on. Find edge Z, begin Z, after motion Z. So after I've found the home switch, then I can do the little hook setting motion that we did before. And that came out of my software as the hook setting. And do it and wait till I'm done with it. And then clear all of the counter registers over here and set them to 0. And then display a message to me that says, hey, I've finished doing all these instructions. So the machine is now home. And that's the end of the pound R program right there, EN. Now we gotta, once we've done it, we gotta have a way to shut it off. So I got a pound S for shutdown. So I've got technically 2 programs in this whole program. So 2 functions. For comment shutdown, first thing I'm gonna do is I'm gonna set the brake. So clear bit 6. Then I'm gonna turn all the motors off. Then I'm gonna turn the powers to the drives off. And then I'm gonna send myself a message, hey, I've done it. And that's the end of the command. So that's my program. So if I stuff that down into the controller using this button right here with the download arrow, and when I move my mouse over it, it says download program from editor. So this is the editor here. I'm gonna download it into the controller. So I did that. And it says, okay, the file was downloaded to the controller. Okay. So now how do I make it work? Well, my command for this is execute, XQ. Whoops, gotta be in capital letters. XQ, and then pound R. And when I press enter, it's going to do all of these instructions. If it gets stuck and has a problem, it will tell me in this box that it's got a problem. Okay, so let's see if we can do it. I'm gonna press enter. Okay, so it did it. And it sent us our nice little message, machine is now at home. If I want to do it again, I can just type the same command up there, execute, space, pound R, and I can press enter again. And that's how that works. And now if I want to shut it down, I can do XQ and then pound S, and it will turn everything off. And it says machine is shut down, and all of our outputs are off, and our motors are off, and we're good to go. So that's how to write a reset program. Okay, thanks.